To introduce the sine and cosine and tangent graphs, we first of all remember a few things about your unit circle. You remember that any point on the unit circle can be represented by cos of theta and sine of theta. And your x-coordinate is cos of theta, your y-coordinate is sine of theta. So what we're going to look at is what happens if we try to make these graphs. So I'm going to start off with a program that I made here. I am going to look at sine first. So what we have here is our unit circle. And I'm going to take off all of these graphs except for sine. Now, on your unit circle, sine is which coordinate? X or y? Y. So what we're going to do on the graph here is we're going to have our degrees or radians along the x-axis and our value of sine along the y-axis. So what this is going to graph is y equals sine theta. Because if you think about y equals sine theta, theta is like your x. That's your angles, so that's why that's on your x-axis. And whatever the value of sine theta is on your y-axis. So if I take this point on the unit circle and I drag it to 0, 0, does it make sense that sine of theta would be 0? And as I go along, so notice as I drag this point, what's happening to my y value as I get close to 90 degrees or pi over 2? Can you see my y value is getting closer and closer to 1? And if I keep dragging it, now my y value is getting smaller until it gets to 0. And in quadrant 3, it's negative. So this blue line on this represents that y value. And if we would keep going around and around and around, I can fill that in. That makes our sine graph. Okay? If we wanted to look at our cosine graph, so I'll turn my sine graph off, cosine graph, our cos is our x-coordinate. And if cos is our x-coordinate, can you see that starting at 0 degrees, your x-coordinate is 1, because cos of 0 is 1. And as you go, now, your x-coordinate, that red line there is getting smaller. Now it's negative. Comes back to 0, and then goes back. So this is your cos graph. And if you kept on going around and around and around, it would continue forever. So these are our sine and our cos graphs. This program also lets us graph tangent. It also lets us graph all the reciprocal ones. No, this is just... So what we need to know... Now, first of all, I'm going to get you to graph these. Just start with the sine one on the side of page 514. When we graph a basic sine graph, this is what we're going to have. I know that your textbook has it graphed there as well, but it has extra grid lines that you don't need that I think make it a little bit more confusing. So when we graph our sine graph, what we're going to do, actually I'm going to erase parts of this. So that you can watch. Okay. The first thing you're going to do when graphing your sine graph is you're going to know that your sine graph repeats itself in one full revolution of the circle. So its period is 2 pi. So the first thing we do is we mark somewhere along our x-axis the period, which is 2 pi. We take our period and divide it into 4 equal sections to represent the 4 quadrants. So we cut it in half. Halfway, of course, is pi, pi over 2, and 3 pi over 2. The biggest that sine ever gets is positive 1. The smallest that sine ever gets is negative 1. So we mark positive 1 and negative 1 on our y-axis. Now to graph sine, we start at 0 radians or 0 degrees, and we think, what is sine of 0? What's your y-coordinate when the angle is 0? Y-coordinate 0. So it starts here at 0. And having split things up into the 4 quadrants, what a sine and cosine graph will always do is alternate between the middle, the maximum, the middle, the minimum. So the sine graph is at the middle. You can think about your unit circle. What's sine of 90 degrees or sine of pi over 2? It's 1, so it goes to a maximum. Then it will go back to the middle, down to your minimum, and back to your middle again. You draw a nice curve through those, put arrowheads on it because the sine graph continues forever. We're going to do the same for our cosine graph. And you can draw your cosine graph on 515. Again, we start with one period once around the circle for 2 pi. We divide it into 4 equal sections. So half is pi, half of that is pi over 2, and 3 pi over 2. Just like sine, the biggest cos ever gets is 1, the smallest it ever gets is -1. And if you think of your unit circle, when the angle is 0 radians, cos is your x-coordinate. What's it equal to? 1. So cos graph starts at 1, starts at a maximum. Cos of pi over 2 is 0. Cos of pi is -1. And it alternates just like last time from going from maximum to middle to minimum to middle to maximum. And this is your cosine graph. So the reason we draw these off to the side is in your textbook they have way more lines than they need. They've got extra things labeled on here. Like they're going by pi over 6 and then pi over 3 and 2 pi over 3. It's a little bit more complicated than you need. All you need are these 4 points. So you need to know 0, pi over 2, pi, 3 pi over 2, and 2 pi. So a couple of important definitions. We'll take out our highlighter. A function that repeats itself over regular intervals is called a periodic function. And the length of each of these intervals, or cycle, is called the period. So in our situation here, how long does it take to start at a point and go to a point? And they used this minimum, and they said, how long is it to go to this minimum? Okay? We could also choose any other point, because the period is going to be the same no matter which point you choose. So if I want to choose the easiest point as far as mathematically figuring out the period, if I choose the middle going up, when is the next time I'm in the middle going up? Right there. Can you see that the distance between that and that one is easily calculated to be 2 pi? Whereas from this one to this one, you'd have to do a little bit more math to figure that out. But our period for both our sine and our cosine graphs is going to be 2 pi. So our sine graph is a periodic function. It has a period of 2 pi. If we wonder about the domain of our sine graph, our domain is everything. Any angle is possible. Now, I'm going to keep highlighting stuff. So this is important. Domain is everything. How do we write all of the x-intercepts or all of the zeros of sine? So sometimes this is easier to go back to our original graph here. Can you see that you have a 0 here, here, here? What's the next one going to be? What's the value of the next one going to be? 3 pi. If you think about your pi plate, if you think about where is your y coordinate equal to 0, you can see it's here and here. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi. How do we write that? We write that as k pi, where k is any integer. Does that make sense? Because we can have 1 pi, 2 pi, 3 pi, 4 pi. We can have 0 pi. We can go into the negatives and add negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So we can write all of those coterminal angles as k pi, where k is any integer. The function has a maximum value of 1 and a minimum value of negative 1. Some other important definitions that we run into with sinusoidal functions. It's your word of the day, sinusoidal. Any sine and cosine graph. Is the amplitude is the distance from the middle of your graph to a maximum, or from the middle of your graph to a minimum. Sometimes what people do is they figure out, well, what's my maximum, what's my minimum? That would be 2 amplitudes. So I could divide it by 2 to find out what my amplitude is. So I'll write that formula off to the side. We've got our definition. Here's our definition, distance. There's a simple definition, distance from the middle to the max. Or we could figure it out. If you figure out your maximum value and you subtract your minimum value, in other words, figure out the distance between your minimum and your maximum, that would always be 2 amplitudes. So you could divide that by 2. Yes? All functions that are cosine or sine graphs, the name for those graphs or those functions are called sinusoidal functions. It could be either the sine or the cosine one. It just sounds like you've got some sort of sinus disease, but no. So your amplitude is the distance from your center line to your maximum. This center line is important, and we have different names for it. So center line, we sometimes call it the average, or if you really want to have fun with it, you can call it the sinusoidal axis. Center line is good for you?
Yeah, I think center line is good.
Oh, saying sinusoidal is so much fun. No. So if the maximum is 1 and the minimum is -1, you've got a range from -1 to 1. So there's our definitions for sine. We have the same things happen with our cosine graph. We still have an amplitude of 1. We still have a period of 2 pi. Again, they chose a minimum value to a minimum value. If you started at 0, can you see at 0 on the cosine graph it starts at a maximum? When is your next maximum? Right here. That distance is 2 pi. That's probably an easier way to see that your period is 2 pi. But this length, so if I drew this length here, from that minimum to that minimum, I could take that, and that is the same from there to there, or same from the center going up to the center going up, or the same from the center going down to the center going down. No matter where I pick a point, if I use that distance, it always gets to another point on the graph that's exactly the same. What does that represent? That represents coterminal angles on your pi plate. If you think about picking something like pi over 6 and adding 2 pi, where do you end? Same place. And so you get the same values. And so that's what your period represents. That you can find all the coterminal angles no matter where you start and where you end. So just like sine, your domain of cosine is everything. But the zeros are a little bit more complicated. So if we go back to our picture of cosine here, if we think about our zeros, we have one here at pi over 2. We have another one at 3 pi over 2. What's our next one going to be at? Think about your unit circle, starting pi over 2, then 3 pi over 2. What's the next one up here? 5 pi over 2. And then 7 pi over 2. So we need to write all of these down. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And to start off, I'm going to get you to describe that to me in words. After 7 pi over 2, what would be the next one? And then? Okay. Is 15 pi over 2 one of them? What about 18 pi over 2? No. How do you know? What would you describe in words? Odd numbers pi over 2. So if we wanted to write all of them down in words, we're basically wanting to say odd numbers times pi over 2. That's beautiful too. Perfect. That's in words. Now that's not a mathematical way to write it. So I'm going to show you two mathematical ways that you could write this, and then you can decide which one you feel more comfortable with. Okay? Mathematical way number one. How do you write any and all odd numbers? It's going to have to involve a k, whereas k is an integer. Okay? I can't just say all integers, right? Because that would include the even ones. Okay, if we could turn it to an even number and add 1, that would make an odd number. How do we make any integer an even number? If we multiply all of our integers by 2, if you double anything, do you see that you'll always get an even number? So to write any odd number, you'll take any integer multiplied by 2, that makes it even, add 1, that makes it odd, and so to write all the zeros of cosine, we can say it's 2k plus 1, because 2k plus 1 is how to write an odd number, times by pi over 2, where k is any integer. That's method number one. Method number two, again, it looks at our graph, it looks at these ones, and it says, let's start with one that we know. So let's start with pi over 2. How much of a jump is it to 3 pi over 2? Plus pi, right? How much is it a jump to the next one? Plus pi again. So a second way that we can write all of those is we could say we can start at pi over 2, because that would be one of them, and then we could add or subtract as many pi's as we would like to get to any other one. How do we write that? We would write that as, so this is method 1, method number 2, start with pi over 2, and add pi as many times as we want, so plus k pi. It's kind of like our coterminal where we added 2k pi, but since we're not having to go all the way around the circle to find another one, we can get there by going around half the circle, so we can add pi as many times as we want, where k is an integer. So again, if you're asked to write all of the zeros of cosine, you can choose either one of those. If there's a multiple choice question, they could choose either form, so you should know them both and understand them both. And just like sine, we have a minimum of -1, a maximum of 1, and so our range goes from 1 to -1. We can finish up by highlighting the definitions of amplitude. That the amplitude is the distance from the maximum or minimum point to the center line. And the last thing that I'm going to introduce you to is the tan graph. We will graph a lot more of the sine and cos graph. But you do have some space at the bottom of page 515. You can graph your tan graph as well. We'll draw our axes. Can you tell me some things about the tan graph that you know? Well, let's just look at from 0 to 2 pi and split it into 4 equal sections to start off with. And just tell me what happens for tan at 0. Yes? We have some places where it's undefined. Yes, we're going to look at that as well. But what is it at 0? Tan of 0 is 0. Tan of pi over 2 is undefined. So just like when you had non-permissible values in the past, in the tan graph, you're going to have asymptotes wherever it's undefined. Where else is it undefined? 3 pi over 2. Does it make sense that it would also be undefined at negative pi over 2? Okay. So we know that tan of 0 is 0. What's tan of pi? 0. What's tan of 2 pi? 0. Now that doesn't really help us graph it completely. What are some other nice values of tan that you know on your unit circle? Pi over 6 is root 3 over 3. It's not quite as nice. Tan of pi over 4. And can you see that pi over 4 would be halfway between 0 and pi over 2? And tan of pi over 4 is 1. And tan of negative pi over 4 is negative 1. Now with those 3 points and with the asymptotes, you're going to find that your tan graph looks a lot like an x cubed graph in that section. Because what a graph does when it gets close to an asymptote is it approaches it, but never touches it. And in fact, it does this over and over again. So your tan graph is also a periodic graph. But its period, how long does a tan graph take to repeat itself? Period of y equals tan x is not 2 pi, it's just pi. It repeats itself every pi. So you take a point like 0, you get to it again going up by moving pi to the right. So this is where, well, we will write down the domain and the range just before the bell rings. We'll start with the easy one, which is the range. Can you see that the range is everything? But the domain isn't everything. The domain has asymptotes. And so for our domain, we can just say the values that x can't equal. Can you see that your non-permissible values are the same place where you cos had zeros? So you can write it, pi over 2 is one of the ones that can't equal, and then plus k pi. So if you use that one or the odd number one, that would be fine. Now the reason why those are your non-permissible values is because tan, big idea, is sine over cos. So wherever cos is equal to 0, you'd be dividing by 0, and that's not possible. Okay.